This is the Amp Hour Podcast, released May 10th, 2021. Episode 541, Chip Shortage Denier.
Welcome to the Amp Hour. I'm Dave Jones from the EEV blog.
I'm Chris Gamble of Texas Electronics. I'm sleep deprived. I'm back.
Sleep deprived.
It's been 4 weeks. I'm back.
Tell
there may
us.
be a baby crying in the background.
Whoa, hang on. Was that an announcement?
That was an announcement. Yes. I am a father, and I've been on paternity leave for the past month. So,
Woohoo!
yeah,
Paid for, both from your own company.
That's right. Analog Life LLC. My boss gave me a solid 4 weeks off. So, don't let them tell you U.S. corporations aren't generous.
Congratulations.
Thank you very much.
There's a baby Gamble.
That's right.
Yep.
Right. Yep.
Yep.
Baby girl, very
Yes.
healthy mom.
Yep.
It's a whole new life experience, and it's been fun. I like it. So.
That's because this is the easy part. You
Yeah,
don't
I
have
know,
to
that's what I
do
hear.
much. It's like, come on.
Yeah. Yep. I think one of my friends gave me advice of just like everything's a phase, and I'm like, yep, that's good. That's my mantra over and over again. So.
Brilliant. All right. So, what happens over there with paternity leave? As opposed to maternity leave. Well, let's speak about maternity leave as well, because this is important. People want to...
Sure. Yeah, I think it impacts things. Yeah. Yep.
Worthy topic. What's it like in the US? Because here, maternity leave, if you're a full-time employee, don't quote me, but the company has to give you 6 or 9 months, or no, up to 12 months, I think, off with no pay or negotiated half pay or something like that.
That's like the federal mandate thing.
Yeah, they have to be flexible. Like, if you're a full-time employee, that's one of the, I guess, downsides from like a financial downside of hiring a full-time employee is that you are on the hook for these sort of benefits.
Sure.
So, yeah.
Yeah, I mean, that's part of a functional society, I suppose.
Yep.
Around here, a little less functional, but the minimum is basically the only thing that the federal leave policy in the U.S. is it's FMLA, Family Medical Leave Act. The only thing it guarantees is that you get 12 weeks, and if you come back, you will have a job. Nothing else, though.
Right.
So that's all it is.
So is that paid leave?
That is not paid. There's no guaranteed paid
federal.
leave.
Okay.
That's right.
Right. Yeah. Okay. Here it's, yep, I'm right. It's 12 months you have to guarantee their job for, and it's unpaid, but I thought there was a paid, or they're allowed to take all their holiday pay or something. I don't know. Yeah.
Some countries have that. And yes, in the States, there are many companies that do that. Some of my wife's friends are at law firms, and they have 6 months paid kind of thing. As like an employee perk kind of thing.
Yep.
And that's great. But it's just not every company or every job. So
is it? Although I don't believe you're protected if the company makes bona fide redundancies. So if during that 12 months the company makes redundancies, and you're like, that doesn't protect you from being one of the redundancies. So unfortunately, but it has to be a bona fide redundancy, and there's got to be that has a legal definition and a legal stance and all that sort of jazz. So yep. Yeah. Cool. And so is that the same for paternity as well as maternity?
There is no guarantee, as far as I know, there's no guaranteed paternity leave.
Right.
But again, a lot of companies offer it as like a perk.
Yep.
Paid or unpaid. And then, in my case, it's all unpaid. Well, it's paid, but it's not,
right. Yeah.
It's coming out of the kitty,
Yep. So did you just stop doing consulting work, or what?
No, I warned my clients about 6 months ago. So they were some of the first people to know that we were having a baby. And so all my projects, I kind of lined everything up as best I could. I have some great clients, and they were all very accommodating.
That's great.
And it worked out. It worked out well.
And of course, you have to tell them. You can't just say, "Oh, I'm taking a mysterious month off." I'm just a slacker. I'm going to be on a beach in, like.
Yeah, right. I'll be out, leave of absence.
Yeah. No, so you had to tell them.
Yeah, I think at that point I'd be like, I'm no longer a consultant for a month, or
yes,
I'll be back at some point if you want to hire me back. If you're desperate for someone in the future, you could hire me back then. But
right,
it is that is the ups and downs of consulting.
Yep.
And actually, so I should speak to a consulting as well. So I mentioned it on here. I started doing a consulting course about 3 months, back in like January, February.
As in teaching it or taking one?
Yeah, so I've been recording it. So I've made a video about it, but basically I've been recording. I've probably recorded about 50 videos just about how to be an electronics design consultant.
Wow.
Because like all the other stuff that kind of I always struggled with when I was getting started.
Mm-hmm.
So, and started making all these videos, had people sign up for it. And I've unfortunately just sat on that mailing list. I haven't even reached out to them. I really need to, and I feel bad about that. But basically, people that were interested signed up as like potential beta members.
Even though you shot the content, is that because you haven't edited it properly, or what?
No, it's all sitting there ready to go.
It's all canned. Yep, in the can.
That's right. It's just there is a tutoring element as well. I wanted to make sure that was like.
Okay. So you're available to right.
Yeah.
Okay.
Yeah,
well, you could just release it. You don't have to. You could just release it as a paid thing. Here it is. Take it or leave it, kind of.
Yeah, there's more.
Or do you think there's value add to?
Well, this is also the beta, so it was like kind of like early, like I did with the first time contextual electronics. I also had done, basically I wanted people to go through it, ask all the, point out the stupid things I did, ask all the questions that I hadn't answered, that sort of thing, and that's really what that's pretty high touch, and so I didn't have the mental bandwidth for that, so
right. Yeah, fair enough.
That's unfortunate, but in the future. It's interesting. I've been trying to reach out to people that I know that are consultants as well, just to get, understand what's tough, what's not. I think there's a lot of interest in it, especially, like in the era of COVID too. I think a lot of jobs have gone away as well. Yep. And so people are interested in kind of.
Or changed,
right? Exactly. Or work remote, that sort of thing. And it's just like the nature of work has and is changing. And so just thinking about that from an electronics design perspective is, like, what does that look like? What do you need to know otherwise? That sort of thing. And it's tough. You may, if you amplify the sound right now, you actually may hear my daughter wailing in the background. So
okay,
yeah,
cool.
yeah, live. We're doing it live. That's right.
So we're gone from dogs barking to
the dog's there too. So he'll come in at some point. It's a true cacophony of sound, and my wife's an angel.
Nice. Yeah. So do you find that there's a significant? How much overlap is there for our industry, i.e. the electronics design consulting industry and other types of consulting industries? Have you been talking to other ones that...
Yeah, so I market it as a technical consulting course too, because it is, so basically I'd say like mechanical, anything with like physical goods, I would kind of put in the same.
Okay, so you're actually designing something, be it electrical, mechanical, maybe even, architectural, if you're an architect or something like that, maybe, or some other.
Yeah, I mean, I'd say, like software, I'd put software in there too, but I think there's kind of.
Oh, there's a significant, okay, yeah, right.
I'd say there are a lot of similarities. I don't know as many software like freelancers or, consultants and things like that, because it feels like the benefits of joining a company full time are so good that I don't hear about it as much, or they're not in my circles or something like that. So I don't quite get as much exposure to that. But I'd say mechanical, industrial design, electrical design, stuff like that. Those are kind of the people that I talk to on a regular basis. That's who I have as a kind of a background with.
Right.
Actually I still listen to podcasts, and thank you for, I appreciate you having all those guests on while I was away. There was some good shows there.
I did skip
People
a week,
haven't listened.
But,
that's okay. Yeah. I mean, but we've had Big Clive's been on our request list for, I think,
since forever.
I think since like 6 months in, people are like, we start to Big Clive. It's like, okay, well, so that was great. And then Fran, and then who was the third one? Last one was
last one was Fran.
No, I know who was before Fran.
Clive.
Who was the? Oh no! Sorry, it was the Missile Man, Bruce Simpson.
Oh, Bruce! Oh, yeah. Oh, how did I forget Bruce? Yes.
Yeah,
of course.
Yeah. No, those were all fun. So people should check them out. They were good.
Yep.
My one friend's like, "Is everything okay, Chris? Dave's recording the intros." I'm like, yeah, everything's okay. That's how you can tell. Something's up, man. Something's up
when that weird ass voice comes in for the intro. Yeah. Yep.
Yeah.
Well, at least I went to the effort to put an intro in this time, because when I've done it before, I always went, nah, I couldn't be asked. You know,
that's right. But yeah, so to like in my late nights and dog walks and all of the things I've been doing in the meantime, I listen to other podcasts, and I think it was on episode not 370, 369, 369. Alicia and Chris over on Embed FM were talking about consulting as well, and there were some good questions about that. So yeah, that's the one. So there was a good discussion in there as well, and they were the person was asking about contracting or consulting after like 5 years, and I think like to answer their listeners' questions,
you're either, it's like Schrodinger's engineer at that point. You're either alive or dead after 5 years, or both, possibly. Yeah. You're both alive, and you go, oh, geez, I wish I was never a consultant.
Oh, you mean 5 years as a consultant? No, This is 5 years as an engineer, and then they're wondering about whether to get into engineering and into consulting. And I think that's interesting because it is. I've had people like reach out to me. They're like, "Oh, like I've been doing this for a year," and the thing that I always talk about is like, and it's something we've mentioned on the show here in the past too. Just if you can get mentors in that scenario, I think you're still in a good place. Yep. But I think the benefit and the thing that people should target always is trying to find people they can learn from. So if they're, if you think you can go out on your own and still find mentors and find people to interact with and learn from, then that's fine. And obviously find work.
Geez, if there was only a forum for that.
That's right. Yeah, that's true.
Go on, plug it. Jeez, I gave you an open shot there.
There is a consulting forum. Yes, there's an application. I'll put that in again. So if you already are a consultant, you can apply for consulting forum.
Ooh, it's exclusive. You got to apply.
That's right. It is a hidden forum because we want to make sure that people feel comfortable talking about things. So yeah, but I think it's just about like, I don't know, like where were you in your career like 5 years in?
5 years. 5 years. No, technically, I was a consultant 5 years in. Damn.
Okay, interesting.
I was.
Yeah, so what was that like?
Well, sorry, I wasn't a consultant. I was a contractor. So I was working for a recruitment company, and they hired me out as a consulting engineer. No, consulting's the wrong word. It is you're hired like on a 6 month or 9 month contract or something like that. So you're embedded in a company. So I'm a contractor. I'm embedded in a company because they've got a project for 9 months or 12 months, and I work on that and then bugger off. Right. Yeah. And then Yep.
You're like a mercenary.
Yeah. Mercenary for hire. Yeah. So I was doing that 5 years in. Yes, I believe so.
And how did it work? I mean, did it go okay?
Oh, yeah. I kept on doing that for a decade. So,
Yeah.
Yep. It had a lot of tax implications I wasn't aware of. Like my first tax bill, I thought, like they weren't, like there was almost hardly any tax coming out or something. Yeah, it was like minimal tax. It was like 10%.
Like, wow, I'm making a ton of money.
And I went, this contracting gig is great, and then my tax bill come back and I did not have the cash to pay for it. It's like, holy crap. It's,
I mean, that'll bite you here too. Like, so like in the States, it's a 1099 versus a W-2. 1099 is like the independent contractor.
Right.
Basically it's telling the government company A paid individual or company B, $5,000 for this work, and so that they can track on both sides of it, and that's great. But then like W-2, that means there's no tax taken out of it at all, actually. And
you're fully responsible for it.
That's right. Yeah, you get hosed.
Liken it to the difference between high school and uni, right? High school and university. High school, they hold your hand. University, it's up to you, dude.
Yeah, that's right.
Like, it's either like
you don't know how to study. That's on you. Yeah.
Nobody cares if you turn up or not. Like,
exactly.
That's on you, right? Yep. So, and it's the same thing on tax. Like, nobody cares if you don't pay your tax, but at the end of the year, you're going to get stung if you don't account for it and put it aside or pay it incrementally or something like that. You've got to do that yourself. Otherwise, you're going to get stung at the end.
Yeah, I think that's actually that's a good point, and I think broadly as well. Like, so things like articles of incorporation. Not articles of incorporation. I'm saying this wrong.
But that's not something I had to do as a contractor. I wasn't my own company or anything like that. I was just there's a different law for contract or a different thing. Yeah, I was just a person. I wasn't a company. So.
Right, and so there are things when you are a company like that you need to have in place. And if you don't know about it, it's like, okay, well, so like one of the things, I think it was like a yearly report or something like that. The dog just kicked in if you couldn't hear
I
that
heard
too.
that.
So yeah. Okay. So we're just living the circus here. But yeah, it's the same thing where if you haven't filed the necessary reports or things like that, no one's going to knock on your door that day. However,
no, it's right. But a few years down the track,
when they do,
yeah,
you are screwed.
Yeah, exactly.
Yeah.
Hey, the IRS put they put Al Capone in Alcatraz for tax. It wasn't for anything else, right?
Yeah, that's right. Yeah, that's
so if they can
get
him, they can get you, right?
That's
so
right.
it's
yeah.
A lot of people don't think. Oh, yeah, it's great.
Yeah, so
there you go.
That was unfortunate that I didn't get that stuff out on time, but hopefully I'll do that in the next couple months and have that as a thing that people are trying to get into.
That is a lot of content canned up. Geez, I couldn't. I'd explode if I was sitting on that much content.
Well, you and I are slightly different that way, I suppose.
We're very different. Oh, boy.
Yeah.
All right. Yeah. So what else has been happening?
For me, just chip unavailability. I don't know if you've been doing any projects lately.
Well, I tweeted this out the other day. A lot of people took it the wrong way, right? They thought I was a chip shortage denier. Right? They think I was a tinfoil hat chip shortage denier. Because I tweeted out that I thought, I've had this on my list for like a couple of weeks, and I finally got around to it. I thought I'll shoot a video on the chip shortage, right? And I won't just mention it, I will demonstrate it.
Yeah, like go through DigiKey or something.
I'll go to the catalog suppliers, and I'll surely, because everyone's been mentioning ST micros, for example, and regulators and all sorts of things. So I thought, it'd be easy to find examples on DigiKey. So I started recording this thing, and I went to DigiKey, and then I searched all ST micros, and then I sorted by stock level. And I'm going, well, there's 57,000, there's 40,000, there's 30,000. These are all in stock. That's
not the way to do
right?
it. Yeah.
And well, that's the thing, right? I thought I can't honestly do an honest video by cherry picking, right? I've got to go, well, there's a global shortage of ST micros. And I went, no, there's not. I had to get to page 12 before I found one with less than 100 stock. Right?
Here's how I would do it. I would do it from the other direction, though. I would find a common design, like like a blue, or was it black pill? Is that what it's called? Like there's some STM32 based like Arduino board, and so like that is like the seed crystal for a bunch of other designs, and
see what the shortage is for those individual parts.
Yeah, exactly. Try and find those parts anywhere in the world, that sort of thing. Or in my case, like NRF52, I couldn't, when I just went to go buy a bunch, I think this was the last time we recorded, maybe, I was looking for those, and I was digging into my own stock just because like I couldn't, there was nothing out there. And that's the thing, like once it is gone, or once it's like your variant's gone.
No, you're screwed. Yeah, it's a Murphy thing, right?
Nothing.
You're guaranteed to get,
exactly.
The part, and So I wasn't implying that it's not happening. I've been saying it's a huge problem. I've been tweeting it's a huge problem for like 6 months or something. But it's I was embarrassed by the fact that I couldn't find anything on DigiKey and Mouse for all of these jelly bean stuff I went for, right? And it was just, this is embarrassing. I can't shoot a video with this,
Yeah, I mean, but if you're also sorting, but I would. The problem is that you can't sort by like the most popular parts. This is my ongoing gripe. I always want to see the most popular parts.
Yeah.
But those are gone. I'd say instead you should like look for the most angsty comments on Twitter. And then just follow that down the rabbit hole.
Once I posted that, I got a whole tweet of angry responses saying, I can't buy this, and you're denying that. And that companies are shutting down because of the, geez, we mentioned on the Amp Hour just a month or two back that, General Motors are shutting down plants because they can't get parts. I mean,
I think they said, I think my one friend told me that like a billion, like two different car companies are going to lose like $1 billion each.
Yeah.
Because of the cars they can't make or something like that.
Shortage.
Yeah.
Yes. And for those who don't know why it's happening, one of the major reasons why it's happening, it's not that the chip suppliers can't open their factories because of COVID or anything like that. It's because the supply chain is a complex
beast
of a FIFO buffer. Like it's a complex of a FIFO buffer, right? It's a like a 6 month long FIFO buffer. And it's like if you're an Apple or you're a General Motors or you're a somebody else, right? You're going to know you're going to need 10 million of that chip 6 months in advance. So you put in your order 6 months in advance, right? And then, but as soon as COVID started happening, all these companies suddenly went, holy crap, nobody's going to be buying a thing. And they shut down and they canceled all their orders.
They went, yeah, nah.
Yeah, nah. You've actually learnt the yeah, nah, have you?
Yeah.
But you've got to say it more, yeah, nah.
Yeah, nah.
No, that's far too American. No, you got to.
Sorry, Dave. I know. There's only so much I could do here.
Where have you learnt the yeah, nah from?
I think Aussie Man, maybe.
Oh,
or maybe
Aussie
you.
Man. Yeah, maybe. Yeah, all right. Okay. Yep. Yeah. Are they the only two channels you listen to? Me and Aussie Man.
I mean, how much Australian witticisms can you get, really?
Right. Okay. Yeah.
Before you go bonkers.
Yep. Anyway, it's yeah, nah. It's. For those who don't know, that's a classic Australian expression. That hasn't been around that long. It's only been around for like 20 years or something. It's like when I was a boy, there was no yeah, nah. So
okay. We don't need the etymology of it.
Right. Yeah. Okay. Anyway, it's just our way of saying we add yeah, nah before, you know, if you see an Australian interviewed on a TV, especially one person who's not used to being interviewed or talking or something like that on camera, they'll go yeah, nah. It's our version of kind of thing.
Yeah.
So it's it's fascinating. Anyway, where the hell were we? I was mentioning.
So you were talking about FIFO buffer.
pipeline. So all of these companies, once COVID happened, like March, April last year, they all went, holy crap, we better stop buying parts because this is going to get bad. Nobody's going to buy anything. So they stopped or cancelled all their orders. And so all the semiconductor companies went, oh, what do we do? Okay, we'll stop manufacturing. And then, 4 or 5 months ago when, it wasn't long after that.
It was like 3 months after. Yeah, 3 months after.
It was about 3 months after that. People just all of a sudden started to work from home. So they had to buy all these monitors and computers and phones and new everything, right? And people were just buying stuff like mad.
I think the other thing too is people had disposable income like crazy because you're not going out.
Exactly. You're not going out. You had extra
after work.
Exactly.
You're not going to lunch every day,
Exactly.
And it's like people are just saving money and they're like, well, I want to buy stuff because I'm American. Although not buy American.
Exactly. So bottom line is all the big companies bet that retail sales would tank, but the opposite happened. There was a boom in retail sales. So once they realized that, they bet wrong. Almost I don't know if you know of a single company that bet right on this and went, whoa, I'm going to buy up all these chips and I'm going to buy it cheap.
That's right.
Let us know in the comments. But all of a sudden, there was this massive consumer demand and there was stock in the buffer so they could fulfill it. But once all that stock started to go and people were buying new cars and all sorts of things, crazy. And once all that stock was gone, all the companies, they couldn't ramp up again because it takes so long to ramp up production of all this stuff. And then all the companies wanted to order at once, right? So there was no shuffled pipeline anymore because a huge part of a semiconductor manufacturer's job is trying to prioritize and sort out is the logistics of having 20,000 different major customers, right? All ordering all these parts. And, so they're very expert at staggering all the orders and, pipeline, optimizing their production flow and everything else. But when all of a sudden you get 0 and then you go to 100, every single one of your major clients, and I'm talking the biggies, right? Your Apples and your GMs, they all want their chips now because all of a sudden this consumer demand and they've bet wrong. Whoa, it's like they can't just suddenly make that many chips for that many customers.
Yep.
So, anyway, all of these companies, they bet wrong and then the manufacturers couldn't supply them all at once their demands kicked in. And it's going to be 9 months to 12 months to sort it back out again. Like, it's just...
Yeah. I mean, the frustrating thing, so they're trying to so TSMC announced $100 billion that they're investing. The US is talking about $50 billion investing. Intel's talking about, we're in the foundry business now. We talked about that last time and all these things. And, they're talking about taking like major action at the federal level and all these things. And I'm just like, it's not going to friggin' matter. It is going to, it's going to matter in a year, right? Or it'll matter in 2 years or 5 years.
No, it's not going to matter. I was going to say.
Sure.
Yeah, well, it's nice having that extra capacity, but everyone knows what the problem is. Like, no one's going to make that mistake again. by canceling all their 6-month backlog orders.
Yeah, no, but they're also talking about they're talking about a couple things, right? One is they're talking about just the straight ahead sourcing issues. Yeah, there's not enough silicon in the pipeline, and just I think the real thing that we need is to unmothball a bunch of fabs, and I don't even know if that's possible at this point, but basically, there's been fabs that have been slowly shutting down in the States over the years. That's probably the best case scenario, I would think, for getting any kind of capacity online. But I have to imagine that they're just buildings at this point, that they sold out all the equipment to
probably
places wherever, right? Because there's capital equipment in there. Why wouldn't you sell it?
You wouldn't leave it there. No,
you wouldn't just let it sit there and
you're almost
cobwebs,
starting from scratch at that point, surely. I mean, it's
right.
Yeah.
Well, and so someone was asking me about this too. They're like, well, okay, so there's 50 billion, proposed for the States. That's great. And I'm like, yeah, that's great. They're like, well, what would it take to like make that into a fab? I'm like, well, if you think it's hard to build, Chris's simple circuit boards, let me tell you, ordering a bunch of dry etch machines or a bunch of, EUV lithography machines. Like, how long does it take to get those? Those aren't just sitting around anywhere either. Those are all
I was going to say, where do the chips come from to power those, right?
Yeah, exactly. So it's not like it's not like Tokyo Electron is just sitting around with like a bunch of stock. They're building to order as well. And so like all this stuff.
No, it's the same problem.
It's a mess.
Yep.
They might have pieces that they could, they have modular etch machines. I was just looking at their site the other day. Like, so they have modular etch machines. They might be able to piece them together, but those are etch machines not going to someone else. So basically, yeah.
And if they've already got the orders in and it's in the pipeline, you can't just, bump orders out. Although that brings me to one of the reasons why I wanted to do the video on the component shortage is that force component supply shortage. I got an email from Bryman, from the CEO of Bryman, because I'm one of their major, distributors. Anyway, to whom it may concern, shall I read it out? Component supply shortage notice.
No.
Why not? Come on. And dear valued customers, Bryman has been receiving delay shortage notices from worldwide suppliers on integrated circuits, passive components, as well as plastic materials. It's not just components, plastic materials as well lately. The delivery situation is getting worse. It's not getting better. And some of our vendors have issued force majeure notices concerning deliveries.
Force majeure.
Force majeure. For those who don't know what that means, it's French for something, I think. Don't quote me on that.
Major forces, basically.
It's basically, it's a legal definition which is either written into contracts or it's embedded in case law or some other, law in your particular country, which means that you can get out of a contract if there's circumstances beyond your control. I.e., you can't get, like, you promise, we're going to ship, 10,000 multimeters on this date, but sorry, we can't get the parts. So you can't sue us. It basically means you can't sue someone for breach of contract. So,
well, you can, you're
not going to win. Yeah. You can sue anyone for anything at any time, but you're not going to win, because force majeure is a legal thing that allows people to get out of basically fulfilling their contracts.
No, it's the fulfillment part.
Yeah.
So it's like, so my buddy, I wish my buddy was able to talk on the show about it, because he's like in this world, but he's like, he was talking about someone who pulled the same thing, and he's like, it's not like Steve Carell in The Office declaring bankruptcy.
Right.
You can't just, I declare force majeure. I mean, you still have to, like, it's basically like mitigating circumstances type of thing. You still have to deliver. It's just you don't have to deliver on the same timeline.
Oh yes, no. Of course, you can't necessarily get out of the contract, but so it means that you can't be held to that date that you promised.
Yeah.
You can't pay penalties because you didn't meet. Like, there's a lot of contracts. People don't know this, built into contracts, that you have to pay a penalty, a financial penalty, if you can't deliver on time.
That's right.
So, it's, and
right. And it's like, oh, well, what if you don't pay that penalty? It's like, okay, then you go to court and you pay it through.
Then it's nasty.
Your lawyers, basically.
But force majeure is one of the ways. Anyway, basically, the CEO of Bryman's coming out and saying, hey, all of our suppliers are saying force majeure. Sorry, we can't deliver those chips as promised. Whether or not that's the situation that, like, a more important customer came along than Bryman. Whether or not, because you can't really prove that behind the scenes, but, it wouldn't surprise me if that was, that was actually happening. But yeah, so it's not just electronic components. The important one there was the plastic parts. They're having problem getting plastic materials as well. So it's not just us electronics.
Right, but that's probably more of a capacity thing than it is like it's not like
but it's the same thing. It's
specialized pellets.
But it's exactly the same issue. It's not like the fabs have shut down, right? It's not like the fabs can't make these chips. They can. There's just so many people demanding them all of a sudden. That's the problem.
I would disagree with that because there's interchangeable parts and there's non-interchangeable parts, right? I posit that many silicon parts are not interchangeable, right? There are some, right? Of course, there's non-silicon parts, right? You can go and get different resistors, and there might be 150 versions of that 4.99K resistor that you need to get. Yeah. Fine, great, that's interchangeable part. But that TI switcher that you've been trying to get that just literally doesn't exist anywhere in the same footprint, that is a non-interchangeable part.
Sure.
Plastics, unless they're using some like plastic mix that is unpurchasable, right?
Yeah, but ramping up and going to another supplier, usually the manufacturer holds the molds and things like that, right? They're really expensive stuff. Sure. You can't just bugger off to another plastic supplier and say, give me 10,000 multimeter cases, right? You got to tool up again.
Yeah, I guess where that difference comes in is the how you define the true cause of interchangeable, not being able to buy an interchangeable part. Right. So in your case, you're saying that the plastics you can't get, it's a non-interchangeable part because you're buying a finished good which is the plastic, the injected plastic from the supplier. Yeah, I guess from that perspective it is.
Unless you already had that manufacturer qualified, right? And they have the tooling and they're qualified and they're ready to go, or you're already ordering from the same part from multiple suppliers just for a backup. I've worked for companies that have done this, right? We would not single source our plastics, right? We would actually have multiple suppliers ready at any one time just in case something happened to that one company. We didn't want to be caught short, right? But most companies won't go to that sort of effort. They go, the One Hung Low factory is just giving us 10,000, things a month, and they don't give a thought to them actually going under or some other crisis happening.
Right, or we'll deal with it when we need to.
Or we deal with it when we need to. Yeah, exactly. Yeah. It's not something,
Yeah, that's true. I guess I was thinking about it in terms of the pellets that are the raw material, but yeah, you're right. If it's purchasing a finished good kind of thing, then it is similar.
And then it's qualified. It can change the whole look and feel of your product, right? The customer might notice, this plastic looks a bit different. Oh, it's a bit more brittle. Oh, does it pass all the qualification, drop tests and ruggedness and vibration tests and everything else, right?
Yeah.
Who knows?
Yeah.
Just because it's plastic ain't plastic, right?
I think that we're entering an age of people taking that step, probably not out of prudence, but obviously some of it's going to be reactionary, or it's mostly reactionary, but it's the cost of waiting is much, much higher than the cost of revising.
Right.
So to use my own example, that switcher chip that I mentioned I couldn't buy, it's gone. It is designed out. So TI, you've lost a socket.
Yep.
And I designed in an LT part or analog devices. And because I could buy it.
What's wrong with analog devices?
No, it's because they got rid of the name, Dave.
Oh, well, okay, right, got it.
Yeah.
Okay.
Because they bought LT.
Yeah, I know.
And I mean, and so in this case, the thing that is interchangeable is my ability to lay out a new circuit board and requalify it based on that, right? That is the lever that I'm able to turn based on that. And the risk is, that the next part goes out of stock or whatever. But basically, having multiple revs of a board now, this is where you start getting into letter revs and number revs on top of it.
Yeah, of course.
I have a rev C1, C2, C3, C4, and all the numbers are because I could only get certain parts with certain builds, and it's just what a mess.
Yep.
So
are you putting down multiple footprints and have you specified multiple BOM items now? Have you learnt your lesson, or you've just switched to one that happens to be available because your volume's so low you just need to do a one-off thing?
That's right. Yeah, I'm still in. Yeah. This is even just for low run prototype type stuff.
Oh, okay.
But at this point, what I do is I don't buy the board before ordering all the parts, making sure I can get them.
Yep.
And even today, actually, Jay Carlson, former guest Jay Carlson, he actually tweeted about the same thing and said basically he will only send out for a board once he has the parts in hand. And I think I'm going to do that as well.
Yep.
yeah, I can't risk it anymore.
I can't. I've lost count of the number of times where I've looked. Literally one day, I've gone, oh, there's DigiKey have 20,000 of these parts. No worries, I'll order them tomorrow when I'm ready to order the rest of the parts. And tomorrow comes around and they're gone. They've got zero stock, and I'm screwed.
Yeah.
Oh yeah.
See, that's what I'm doing right now. Right. I'm taking a similar tact. I'm saying I only when I get the PO or whatever will I or get the invoice will I send out the board.
Yes.
This is actually saying once I actually physically have the parts, because even having the until they're actually shipped to me.
Yes.
They don't. It's a Schrodinger part type of thing. It doesn't exist until it's in your hand.
So but you will trust the shipping notice from DigiKey and Mouser. So then you don't.
No, that's what I'm saying. Not anymore.
No, you won't even trust the shipping notice.
Nope. I will have parts in my lab, validated.
What do you think they're going to ship you the wrong parts?
Sure. What if I ordered the wrong parts? You know what I mean?
Oh,
like
right.
it's just
okay. You could have ordered the wrong.
At this point,
okay. Right.
Yeah.
Well, if you don't want to trust yourself at that point, yeah, okay.
I mean, no, this is just
fair enough.
Being burned a bunch of times, and it's just like it's just the next step in the progression of of being paranoid. It's just because it's not like the boards are expensive, but the time's expensive. So it's better to basically burn 2 days in order to get the parts in hand and validated then send out the board versus get everything to the assembly house and it turned out actually no, that one part wasn't included in your order, and now you have to go spin your board again and then do everything again over again. And it's just I can't burn that 2 weeks of the cycle time, because even if I'm using a board house that has a 4-day turn with shipping from China, it's like, okay, that's a solid 2 weeks. And by the time the assembly house looks at it and says, oh, nope, sorry, you can't get this part, and I have to go respin the board, it's another 2 weeks. And so it's just like, it's better to burn 2 days up front than lose 2 weeks on the back end.
And
it sucks. It sucks because
make sure you have those spares as well, because when they manufacture, there's going to be X amount of loss. And at this point, they may be scraping them off the pick and place assembly floor, and they might be and then hand assembling.
Oh, I've been sending in parts. I think I mentioned this last time, but I've been sending in parts from my personal stock to just to fill out the order because I couldn't get parts anywhere else. So I just had to send in. I had to send in the parts I had, and it's fine. Slight variance on microcontrollers, things like that. Just got to get something in hand. Because like, what else are we gonna do? This is what we do for a living.
Exactly. Oh boy. Anyway, and it's not going to get better anytime soon. As the once again the president, sorry, not CEO of Bryman, said, the chaotic set will not. He can't see it improving in the next few months at least. So he's basically saying, sorry, but we have no timeline when this is going to get better. So that's the CEO of a major corporation, telling us directly, like.
Yeah, the other way I've explained it to people, I've explained this to family members. Like, they're like, "Why are you stressed?" I'm like, "This is also, it's like, like you mentioned a FIFO buffer. That's good for people on this show. But I think explaining it to other people is like, it's like a car crash, right? So you're sitting in traffic now, and all of the, the car crash has happened. They've cleaned up all the bits of the car crash, and you're still sitting there for another 4 hours.
You're stuck in the traffic because everyone's going slow,
you're stuck in traffic,
and then you have to wait for the person in front of you to move on, and then
that's right. Right. So the car crash in this case is getting all the silicon necessary into the wafer starts, and then my car moving is, but by the time the chips have been all the way propagated through the supply chain and sitting on a distributor shelf, and I happen to catch it in time, because it's very likely that even if the order date is, if DigiKey or Mouser says, oh, there's 20,000 parts on order, that's great. If I get swooped, I called it swooped on Twitter the other day. If someone swoops in and buys all those parts underneath me, like, I'm screwed, right? So I could outlay the cash now, but it's just like, it's a cash flow nightmare. And also someone had proposed that it'd be called reeling. I'm reeling from being swooped, like reeling, like a reel of parts.
We're here all week. Yeah.
I like it.
It's all right. Once again, nobody outside the industry will get that. No one will get it. It's like reeling. Okay, you're like, as in reeling a fishing line or whatever.
Like Steely Dan reeling in the years,
Right. Yeah. Oh boy. Yep.
Yeah.
Anyway, big problem. Can we label this one? What was it that I labeled myself at the start, or people were labeling? Well,
Oh, chip shortage denier.
Chip shortage denier. Yeah.
Yeah, I like that. Yeah, I think that's good.
All
I'm
right.
sure there's a photo of you somewhere with a tinfoil hat
There
on,
is
right?
a photo of me with a tinfoil hat. Yeah, I can send you that. There is.
Great.
Yep.
I will take that.
All
Yeah.
right.
Great.
All right. Remind me at the end of the show to send the tinfoil hat.
Good. Yeah. Yeah. Really, really important stuff that we're doing here on the Amp Hour.
Oh yeah, totally. Yep. Because I'm an Aussie, and it's like I don't give a shit about taking the piss out of myself. I'll post that thumbnail of me wearing a tinfoil hat. It's just for shits and giggles, right? Yeah. Anyway.
Yeah, it's going to be bad. I mean, so, and like I said, if you're not being careful now, there's someone else too on Twitter was like, when you saw these shortages happening 3 months ago, why didn't you buy 6 months of stock? Which is part of the problem as well, by the way.
Yeah.
And it's like, man, I do 2 designs a month. Like,
right.
Like I would love to have bought all the parts that I need for the next 6 months, but that's not how this works. Like,
well, you've got to have a cash buffer in your business to take care of that. That's
cash. Oh, cash is a different problem. That's not a problem for me.
Right.
Like, luckily.
Then what was the problem?
The parts that so if they said buy 6 months worth of components that I'll need, the components that I'll need in 6 months from now. Like, I don't know what sensors I'm going to be designing for some client that I don't have in 6 months from now.
You're talking about new design. Okay, right. Okay.
Oh yeah, right.
Not making
if
it
I'm building
in
the
6
same
months'
thing.
time. Yeah.
Oh sure, yeah. If it's a manufacturing thing, then yeah, of course. But that is a cash problem.
Yep.
Yeah, no, this is a design problem. I play a little towards the front of the design cycle. Yep. Manufacturing's got a whole bunch of other issues.
Mm-hmm. And this leads us into the often. This was like a whole Altium's vision, and everyone else's is the modular electronics thing. Oh, if you've just got this little switching controller here, if you just standardize on this switching controller and you do your layout and that's it, it's done. You can use that in every design forever. It's like, no, not quite.
I mean, that's fine, but then you also have to be sure on like a to the microsecond accuracy type of thing that your switching controller has the exact same behavior. If it has any different behavior, that could just propagate all the way through your system.
Or if you need a different efficiency, you need a different price point, you need a different whatever, insert
right.
difference in design here. There's a dozen of them.
Yeah.
Right. Then that entire concept falls apart.
Right. I like the idea, like modularity in general. Like I like the idea. There's always higher cost to it. That's fine.
Mm-hmm.
Like some industries can handle that. That's great. Like I think about it. What it really is basically you're making modules much like standardized chip pinouts are. You're making little modules that now have its own standard pinouts, and that could work. It's just that there's a whole lot of investment to do that sort of thing. If you did invest in that a year ago and you made your whole design modular, then you're probably doing pretty great right now, right? You can't get switcher ABC 1 2 3. Well, you've got
it depends on the business you're in. If you're a consultant,
sure, yeah.
If you're a consultant, as we're talking about here, you're working on vastly different designs from one, every couple of months,
right?
Maybe,
sure,
right,
sure. Right,
and you can't do that. You can't just
Well, and that would work in a prototyping context for sure. I mean, if you were, so like you just plop down your switching converter, 5 volt to 3.3 volt footprint. That's basically just a tiny circuit board just going to drop on there with like castellated edges or something. That works great. And, then it's super switchable and you can, you can swap in things as needed. But are you willing to, use that space and the cost and the overall complexity to put that into your final goods? It's like, okay, probably not.
Yeah,
so
exactly. And there's a difference between what type of products you're working on. Are you working on a consumer product? Are you working on high volume, low volume? Is it a 1-off? Is it a 10-off? Is it 100-off?
Sure. Yeah. I think the modularity makes a lot of sense towards the the lower volume side of things for sure. If you because you probably have more margin, because you probably have weirder requirements, you could really play with that well. But I think that a lot of people that are doing electronics, they're getting paid because there's higher volume needs, and they're getting paid to introduce efficiencies that modularity is kind of the opposite of.
Okay. Can we get on to, because, well, we've got the whole bloody show about the component crisis, and which is all COVID driven. Can we talk about remote working? It was on the list.
We can.
America's super cities are coming back.
Oh, we've talked about this.
Remote work is overrated. Have we talked about that?
Well, we called it before this article was written, I think. I mean, yeah, basically, I don't think people are leaving the cities, like young people want to be around young people. I'm pretty sure I've said that exact thing the last time we talked.
Probably.
So,
so there's nothing new there. Did we? All right.
I think actually we might have talked about this. Yeah, this is from a month ago, so maybe we talked about this. But personally, I think, so my workspace is coming back, and I'm vaccinated. Did I tell you I'm vaccinated?
Yes, yes, you
fully
did.
Vaccinated. Yeah. Woo, woo, get the vaccine if you can.
I wouldn't celebrate too much, dude. It doesn't necessarily give you a lot of your freedoms back. So.
Oh yeah, I mean that.
Just be careful.
It's a shit sandwich. Don't worry about that. But, but I'm very happy to have it all the same.
Right.
So, but yeah, I mean, like the M Hub is coming back, and so that's nice. And I just feel like there's people want to be around people. I don't know. Yeah. Maybe less so in our listening crowd.
I was going to say engineers are like, I don't care if I don't see another human for 6 months. It's like, yep. It's just engineers. Yeah.
Sure, but those engineers need work, and I think a lot of that work comes from other people being around one another and generating economic activity. So
right. Well, there's lots of economic activity in toaster design.
Oh yeah. Oh, what about it?
Chip of the week.
Is this a chip you can actually get?
This is zero in stock on DigiKey, unfortunately. A 32-week lead time. So there you go. Here's the example. So if you're in the toaster business, you're screwed because you can't get your PT8A2514 APE chip, which is an 8-pin dip. None of that SMD rubbish. 8-pin dip. Because, it's still cheaper to do dip single-sided through hole than it is, surface mount in a lot of cases. Depends on where you get it manufactured. Anyway, this is a toaster controller chip from Diodes Incorporated, and it's kind of cool. It's just an 8-pin chip, and it's got a bagel pin. I just want it because it's got a bagel pin. It's great. I don't know what else to say about it. I just think it's chip of the week.
I'm pretty sure we've actually talked about this chip on the show before.
Oh, really?
Because I remember talking about a bagel pin.
Oh, okay. Yeah. Is it 25 days ago? Oh, okay. Right. Our list is
No. I think actually a long time ago.
Oh, really?
So. Yeah. I don't remember, though. I just remember a bagel pin.
Okay.
Maybe it's just
come around again.
On Twitter or something. But yeah,
it was on Twitter.
It is interesting that
somebody discovered it
again. It's like super...
targeted, niche.
Yeah, exactly. Application specific, right?
Yeah.
Yep.
Oh boy. Yep.
Speaking of targeted chips and people making them, so this is actually something I meant to mention on the show the last time we recorded, but I completely gapped on it. But Matt Venn, past guest of the show here, he's doing the Zero to Asic course. So he's teaching people how to actually use like all the tools to target and make silicon for the shuttle runs that Tim Ansel and Mohammed Qassem has been on talking about. And so he's been doing this course, and he's also doing a podcast where he's talking to all the people, not all the people, but a bunch of people that are actually making the chips that went into that first shuttle run of the chips. So if people don't know, Google had sponsored a shuttle run through Skywater, the Skywater PDK we've mentioned on the show before as well. So it's a 130 nanometer design node, and basically Google sponsored people to go and submit chip designs. Yep. And so Matt has been documenting it.
They had to be open source though, didn't they?
That's right. Yep, that's right. Yep. And yeah, it's really interesting kind of hearing why people are doing all these different things. There's some familiar names, some new names. And so there's a Zero to Asic podcast though. And I've been listening to it and really, really enjoying it. It's great. So another podcast to add to your listener if you haven't already done it. And there's also videos. So
cool.
Yeah.
Cool bananas.
Highly recommended. Yeah. Dan Rodriguez. This is actually, yeah. So Dan Rodriguez is the one this past week. I was watching his thing, and at the end of the show, that episode rather, they mentioned I was going to almost put it on our list, but I figured I should just mention it. They mentioned the 2016 talk called the Ultimate Game Boy Talk or something like that. It's an hour-long presentation from 2016's Chaos Communication Congress. And oh my God, it is amazing. It's like a deep dive into how everything works in a Game Boy, like all the
Nice.
sprite generation,
Yeah.
all that stuff.
Yeah.
Oh man, highly recommended. I still have to finish it, but like just 8-bit graphics and all that, the stuff I just never really understood, and it's just such a great summary of that sort of thing. So we'll have lots of links in the show notes for this stuff.
Yep.
You can tell I've had a lot of time to watch videos. Can you tell? a lot of slow, tired days in my past month.
Yep. One of the most amazing videos comes from somebody I've never heard of, TK. It's hand drawing a RISC-V CPU, and sorry, I forget if it's RISC-V or RISC-V. It's RISC-V.
You started right this time. Yeah, so that's good.
Right,
yeah.
RISC-V.
You always ask.
Yeah, I always because I don't.
You're getting there.
I just don't
you're getting there.
Care.
Hey, you're getting there. That's
right.
good.
Very good.
No,
RISC-V CPU and playing. It's somebody hand drawing a RISC-V schematic, right? An actual RISC-V processor, and then it magically goes from paper to CAD, and then they simulate it, and then they play a thing on it. They actually run code on it. It really is. Geez, it's like, yeah, hats off.
It's amazing. Just, yeah.
it's absolutely incredible, and it just simulates the processor
and like seeing all the fact that it's actually like logic gate level. I expected it to be more like when I first saw the title, I was like, oh, it's gonna be like high level blocks, but no, it's down. It's down in the gates.
It's got individual gates. It's got muxes. I don't know how they're actually doing it well. How would you feed it? I don't know. You got to feed in the pixel data. It's I don't know how they're feeding in the pixel data that allows it to, because it's doing all this animated, it's doing an animated display thing. So the trick is like feeding in the data and stuff like that. So it's not as advanced as you might think it is, I guess, maybe, but it's bloody impressive. Jeez. I'm blown away. Yeah.
Yeah. I mean, I don't even know where to start on this stuff. Like on, chip architecture and things like that. No, there's nothing going on up top for me.
well, this was all like when you learn digital electronics, all these basic building blocks of what you learn. You learn your ALUs and your arithmetic logic units, and you learn your adders and your subtractors, and you learn all these building blocks of stuff, and I don't know if they still teach that these days. Do they? I don't know. Any young whippersnapper students out there learning digital electronics 101? Do they still teach you, ALUs and whatnot?
I think they're doing logic level, and they're doing Carnot maps and all of that kind of stuff. But I feel like that's a big leap up to then piecing those together and building an ALU from a bunch of discrete logic elements is like is something special. I think I mentioned on the show before, but there is a course at the University of Michigan that one of my friends took that is basically in a semester you have to go and design a fully custom processor all the way from scratch.
Right.
And
okay,
it's,
cool.
It's like that's I definitely mentioned on the show before, because it's like that's the course. If you'd pass that course, you're going to get a job somewhere. Basically.
Oh yeah, but that's a specialized course. That's not something you do in a general degree.
It's computer engineering. Yeah, it's like the advanced, the most advanced version.
Of course, if you're doing computer engineering, that's different to just a Joe Blogs, engineering degree.
Yeah, right. You're only going to do that if you're really into it.
yeah, exactly. Cool. That's just it's just great. Just the amount of effort to hand draw that, and then enter it in and then get it working. I'm sure it's like the 5-minute video actually belies the number of hours involved in this. It's it's huge.
Yeah, there's other videos we have on here too. So like in terms of like computer architecture and kind of following all this stuff. So obviously we've had Ben on the show before, Ben Eaters on the show, talking about this sort of stuff. He's building up from 6502. This is basically taking down another level.
He builds the breadboard ones. Yep.
Yeah, right. And so this is taking down another level and like doing it from there. There's another video from January of 2020 of last year rather, where there's a relay computer. And that's another good one where it's basically like at the Altair 8080 level, where they're building out things from a, just watching logic operations happening. And it's super possible to do this, right? So the person who did it on paper, That's one way to do it. Obviously, you could do it the relay method and watching how bits propagate through. It's really interesting to see this stuff. I think then building it all the way back up. So then Matt and the Zero to Asic course, right? That's basically now saying, let's do it from the software level and define it at the software level, or even going above that. When like Michael Gieldo was on the show talking about some of the simulation things happening with Renode, I believe. Yeah, so there's just like all these different layers and like where people want to specialize and learn these things. It's kind of like how much under the hood do you already understand, or do you want to understand?
Mm-hmm.
I feel like if someone wanted to submit something for a future like Skywater PDK or Skywater shuttle run, you're probably going to be doing that at the level of Verilog. You're going to be using some of the design tools,
of course.
But if you don't understand the stuff underneath, you might end up overdoing it, where you might have more logic in a certain area. You wouldn't be able to check your work underneath.
Mm-hmm.
It's kind of
right.
The equivalent being like can you read the disassembled code?
Yes, that's right.
And understand like whether it's efficient or not, and that might have big implication. If it's if you're writing C code and it generates a crazy amount of assembly or machine code after that, it might not be a big deal until you're at the end of like you're filling your chips filled up 96%.
You're trying to optimize it, and
yeah, exactly. And then so same thing happens with the Skywater shuttle runs, right? You're going to have a certain amount of space there. If you get to the edge, you're probably like, oh, I have to make this more efficient. That's when you really need to understand the stuff underneath. And so it's kind of like,
where Chris, everyone knows you just buy a bigger memory chip, bigger memory processor.
Well, when you only have a certain size, I mean, this is the rubber hitting the road on that side of things, I think,
Oh boy. Yep.
Yeah. It's a crazy time we're living in that this is available, though. Like the fact that people can just go and build ASICs, and that's great.
You want to know what defines crazy times that we're living in?
What is that, Dave?
When your LG dryer, i.e. the dryer that dries your clothes, not only connects to the internet, but uses 1 gig of data a day.
Yeah.
Like
that is some software written by a JavaScript engineer.
I almost can't.
We're logging everything.
Yeah, I almost can't believe that's real. Like the person who posted this on r/smart home, they postulated that do they have a compromised device, i.e. is it mining Bitcoin in the background or something, like that? And you would have to suspect that, because you would, as an engineer, you would think, how could you possibly design a dryer like that needed 1 gig of bandwidth a day? Like, surely you would know this during the development. You'd go, hey, this is not right. Come on, this is bullshit. Right. So,
yeah.
No,
I mean, I think, if you had some like crazy logging, like still turned on,
yeah,
right? Say your firmware version, I just had it logging every, I don't know, 10 milliseconds, 10 microseconds, whatever. Like I think it's pretty plausible that you could get up there pretty fast.
Well, yeah, I guess.
How much data you're sending back.
Well, yeah, like it doesn't, well, I was sending video, I guess. Back when I had a data cap on my internet connection here, I could not leave even a low resolution 320 by 200 webcam running 24/7 here, so that people, you used to be able to log in and see me working in the lab for whatever reason. I couldn't do that because I would use up my entire monthly data cap in like a day if I actually streamed it 24/7 or 2 days or something. It was just, and that was only low resolution, let alone high resolution. So just stuff adds up if you're doing it all that. But like, your dryer presumably only logs this data when it's actually operational, which is like what, an hour a day at most. It's not like it's
sure. Yeah.
I guess. I mean, it's just, it's insane. Like, yeah. I just like.
So let's do a little back of the. I mean, I'm gonna add a calculator in front of me. It's not back of the napkin, right? So
you don't have a calculator in front of you, Christopher J.
I do
Gamble.
have a calculator in front of me. I do have a calculator in front of me.
No, none of that Windows bullshit. Real physical calculator.
No, it's a Windows bullshit.
Yeah, no, see, no, fail.
I don't do calculators. My last calculator was a TI-83.
No, I'm sorry. You're gonna have to hand back your engineer's
That's
ring.
right. Engineer card. Yep, that's right. But that would be 10 or 11 megabytes. Some of my math's probably off here, but that'd be about 11 megabytes a second, right? So
I say, yeah, it's giga B, it's capital B, so it's 1 gigabyte of traffic.
Right.
So if you've got 1 gig,
Right.
1 times 10 to the power of 9 gigabytes, right?
Right.
And
divided by 24.
Divided by 24
divided by
hours.
60.
Divided by 60.
Yep.
Divided by
that's minutes.
60 again.
60.
Second.
So
second. Right?
Yeah.
That's 11K.
11 and a half megabytes. Right. No, megabytes.
No, I get...
Or sorry, kilobytes. You're right. Yeah, you're right. So
11,000... Yeah, bytes. 11,000 bytes per second.
Yeah, let's just stay in bytes. That's a good idea. Yeah, it would be kilobytes. You're right.
It's 11 kilobytes per second. That's actually not a lot. But as I said, this doesn't run 24/7, right?
That's a good point. But if they had logging turned on, right? So imagine they didn't turn off the debug flag in their compiler, right?
We've got a segue here. Yes, I believe.
Yeah.
Yeah.
And like then 11K per second. But then say you're doing it every 10 milliseconds.
It's very verbose, if you've got lots of verbose logs.
1,000 bytes.
Yeah.
But I mean, if you're writing, say you're writing log messages, that could very easily get it.
And human readable log messages, so they're strings.
Right. So 100 bytes per 10 milliseconds.
Yep.
Like I've done that. That's easy to do.
Yep.
And it adds up though, right? I mean, if you're logging it back to a server, that's kind of crazy.
This is not the Voyager 2 space probe where every bit matters, where they pack every bit, and you have to, the amount of decoding you have to do on the other end to deconstruct each individual bit is, incredible. Now it's just bandwidth is infinite, right? So you send out text strings.
Yeah, exactly. ASCII or like.
Yeah, of course you're going to send ASCII. It's like.
Yeah. Is there a segue to whether or not you do printf debugging? Is that the
that is the segue?
No?
I believe. I haven't looked at the segue, but I believe there's a segue for that because even 20 years ago I was putting in text, debug log outputs because it's just easy. Just hook up a serial terminal and it's like there's your text, right? You can read it. You don't have to remember that, this bit means this. I mean, that's just dumb, right? Because then you'd have to get another step to process it. So you just turn on your debugger and your code spits out the message, it's, sample 1 taken or something, So it's just easier. But you wouldn't necessarily put that in production code. But, I've taken that sort of, like I've put that in during development and taken out in production because, it's just sacrilege,
Right. Yeah. So this is kind of written from a higher level language kind of thing. I mean, I think that's the person who wrote the printf debugging thing. I actually think that it's a big switch to when you do step debugging or when you're doing, you're running a debugger, you got a JLink plugged in, that sort of thing. I feel like that's graduated. It's like important from my perspective, but it's going to be a mix of all of them, right? I think that having a serial terminal spitting out stuff, as long as it's not like super timing critical, having LEDs available, having printf out to a serial terminal, like that's all really important. But
is it worth a couple of K? Because people who don't know, and we've probably talked about this before, on a microcontroller where kilobyte, you have kilobytes of memory, not megabytes, right? It's measured in kilo. If you're really luxurious, you might have 128 kilobytes or 256 or something, but we're still talking kilobytes.
I was gonna say,
right?
Dave's working with older parts here.
Right? No,
it's cheaper than it used to be. That's for sure. But you're right. No, the 128, 256. You're right. Yeah, I think that's right.
Right. I'm talking about your 8-bit micros, right? I'm talking about your AVRs and your PICs and your whatnots, right? Your 8051s and whatnots, right? We're talking tens of kilobytes, sometimes under, and just the act of linking in the printf code adds a kilobyte or two to your, I wouldn't be the first person to write my own printf routine because I didn't have enough space available, right? I couldn't link in printf because I couldn't afford the 1 or 2 kilobytes that because when you just using your printf just once in your code, it means you've got to link in the full printf library, right? And there are optimized compilers that kind of, I know about all that sort of jazz, but
sure.
But still, it can take up a couple of kilobytes just because you added one line in your code.
Yeah, right? Totally. I have a callback to earlier with sourcing stuff. So the parts that I had on hand, I had a different code of part, right? So it was actually half the memory, half the RAM, half the flash, half the RAM. That's what I had available to then send. Like I said, I couldn't get the parts anywhere, and I needed to send in was an NRF52 that I was using, right?
Yep.
So now my code base now has to shrink in half,
right?
And Nordic does not have a small Bluetooth thingy in it.
Yes.
The binary blob is huge,
Oh
and
yeah,
so
it's enormous.
basically,
Yeah.
and so I'm doing that now, and I'm going through and I'm just turning off everything just to try and squeeze stuff down, right?
Been there,
done all the printfs. There's multiple ones in
Yep.
there. There's different libraries. There's like all of their libraries, which are super, they're
bloated. Come on.
They're bloated. Yeah. I was just saying nicely written, and I'm like, they're not nicely written. They're thorough. They are all inclusive.
Thorough. It's not I'm not bloated. I'm thorough.
That's
it's
right.
a t-shirt.
Right.
Yeah. Right.
Right. And so they've got tons of options in there, and so it's like so it's like either I go write my own, which is it's got its own pit of vipers, but it's like it's tough to do this stuff. So you have to decide, like, do I need that printf debugging or not, or do I just rip everything out? Maybe I have like a preprocessor thing that I don't include it, or I do include it, or whatever. So yeah, in that case, I specifically had to then go and rip everything out because I couldn't fit it, because I had a smaller part than I thought I would.
Yeah.
Because of sourcing problems.
Yep.
So, yeah.
Those were the days. No one cares anymore. Everyone's using their bloody, STR micros with half a megabit of bloody megabyte of memory in them.
Well, unless they can only get the 256K, and then
shock horror, because you can, because your component shortage. Gosh darn it!
That's right. I mean, that's exactly what just happened. Yeah, that's what I just described. Yeah, I mean, it sucked. Yeah. So I don't know.
That is one of the advantages of choosing a micro that has tons of variants like that, because like a lot of the times the footprints will be completely compatible and you won't get caught short, because okay, look, I've got to spend a bit more money, but hey, I can buy the 512 meg version in stock where I only need the 64K, but heck, it's like it's the same pin out, everything else is the same, and I just have to tweak a line in my code to like or a compiler switch or whatever
strapping.
It's nothing burger, and you can continue to use your part. So there's advantages to that.
I mean, it depends on different parts that have different number of variants. Some of them have, I feel like the ones that have the most variants are the ones where they're just turning things off with like laser.
Yep.
What is it called? Like the blowing fuses at the end of the process.
Right. Yep. Although I've been bitten by this before, because I used I think it was like a 16K variant or something, and it worked fine. And I decided, just for production, I'll go to like the 64K variant to leave me plenty of room or whatever. Right.
Oh, yeah.
So I go to the 64K variant, didn't work, because because the 64K variant had silicon bugs that the 16K variant didn't, even though it was an identical chip, identical pin out, right? It's just a different slash number at the end or whatever. It was a physically different, so silicon in some way, and it had silicon bugs that the other one didn't.
Oh wow! So somewhere in that 48K extra memory, that's where the problem lurked.
I don't know. Somebody goofed up something, when they actually compiled.
Or maybe like an address line, one of the bits.
I don't.
For the address line or something.
I don't know, but that can happen.
That's
like,
crazy.
That can ruin your day.
Yeah.
So.
Yeah.
Yep.
Yeah, so when Sammy from FNX was on, he was talking about the different FPGAs that they make. And it was interesting looking at the masks that they have, because I had never really looked at, they had like a chart that I think I linked, but they had a chart that showed kind of like the different part variants and all that other stuff, like the different BGAs you can get and the different sizes, whatever. But it actually when you zoomed out, it actually showed like, oh no, there's actually like 3 different masks that they bought. So there was like 3 discrete chips that they were making at the fab, right. And then you could choose within there. And I never really thought about that before. Like why wasn't it, so like if I go to an NXP or something, why aren't they all just the same part? And it's because that same thing, there's different actual mask sets that are, maybe it's just, maybe it's not the entire mask set. Maybe it's just maybe it's the metallization layer is different on some of the parts, but they are different chips. And so the customization or the part number variants can only be as much stuff that's actually in the silicon. I'm not sure if anything I'm saying is making sense, but you need to be able to actually have the silicon under the hood that you then can, blow a fuse and enable or disable some of it.
Yep.
So I had never really seen it presented like that before, though, because I think other chip companies kind of hide that stuff.
Got it.
So it's interesting to hear about that.
There you go. I think we're way over, dude.
Yeah, we wouldn't know because we had.
We had a few goof ups. Yep, Zencaster spat the dummy on us a couple of times.
Yeah.
At your end, not mine. Nothing wrong with Australia.
Yeah.
Yep.
Yeah. Australia has perfect internet.
Yeah. Anyway.
Yeah.
I have to try and figure out how to get internet into my new storage unit, which I got.
Oh yeah.
So that's a bit of news. Yeah, breaking news. Got a storage unit. Did a video on that.
Mm-hmm.
And I got to figure out the most cost-effective and easiest way to get internet down through 5 stories of concrete down to my storage unit. So
Sneakernet is the answer.
Sneakernet. Anyway, there's a thread on the EV blog forum for that. If you want to, throw your suggestions. People said wireless, get really powerful wireless transmitters. I'm going, 5 floors of concrete. Kind of doubting that. Stick it on the outside of the building. Not quite.
Oh, actually, one thing I did want to mention before the end of the show is I have a robot bassinet. I meant to mention this earlier.
You told me. You told me about this, and it rocks the baby back and forth, and you're about to enter the. You're about to enter the baby market, aren't you? I can see the cogs turning, dude. I can see the cogs turning that you're gonna.
Oh, you mean as a product
as in a product development?
I think I mentioned when you and I talked about this. It would scare the hell out of me just because of like the product liability.
Side of things. Yeah.
But it's very interesting. Just like I think it's one of the first. I mean, it's like a high end thing. So it's called a SNU, and I rent it because I can't afford to buy it. It's because it's expensive. Because
it's a motor. It's a motor in the bottom of a bassinet.
I know, but it's co-designed by Eve Behar, one of the Apple designer people, and so it's like super fancy design stuff.
It's a motor in the bottom of a bassinet, folks.
I mean, yeah, that's right. But also, no, it's also got sound detection and then an app.
Of course, it's got a freaking app.
It's fantastic. Let me tell you, I love the app.
And how much data is it uploading per day?
That's a good question. I don't know. Someone should reverse engineer it, but it is awesome, and it's some electronics that I didn't expect to have in my life, and now I do. So
unbelievable.
I don't know.
What's the world coming to? Yep.
Robots.
Yep. Oh boy. Yep. We're still nowhere near, robots and Wall-E. AI and all that sort of thing. But while you're away, Chris, Elon Musk finally admitted that, the self-driving thing, we're nowhere near the AI required to actually do it,
right.
Yeah,
I think he owes you like $20 or something.
Yep. He owes me. Bastard.
Yeah, exactly.
Yeah, duh. Anyway, that's it.
Okay.
Welcome to the fatherhood.
Thanks. It's quite a club.
And it just gets easier from here. Trust me.
Yeah, that's what I heard.
Yep.
All right, I'll be back and asking you more tips next week.
Catch you next time.